Okay, now that we've got our head around some of the grade 11 financial maths with the compound and simple interest and all those kind of things, we're going to look now at what we call annuities. And annuities are normally characterized by large sums of money either being paid out or being paid to you in equal payments. They could be monthly, quarterly, yearly, but as long as you've got equal payments coming on a regular basis, that now characterizes an annuity. So we've got two types of annuities that we deal with: present value annuity and a future value annuity. And the equations look as follows. So my future value annuity, which we will write as F subscript V, is going to be X into bracket 1 plus I to the power of n minus 1, close big brackets, and all of that stuff there divided by I. And we've got now the present value annuity, which is P subscript V, and that's going to be equal to X, open square bracket, 1 minus, open round bracket, 1 plus I, close round bracket, to the power of negative n, close square bracket, all divided by I. So now, if you look at these two equations, my FV stands for future value, my PV stands for present value. The X represents the equal monthly payments, or the equal annually payments, or just the equal payments that you will be receiving or making for this annuity. Then that's 1. I is simply your interest rate that you're going to be dealing with. Obviously, it's going to be divided by however many terms. So if it's like a monthly annuity, it's going to be, let's say, 0.1 if it's 10% divided by 12. N is a number of terms in that entire period, and then this I again is the same I as the one above. And then the same thing here. So how we get these formulas, we basically just use now our sequence and series for like a geometric sequence and series. You can watch this proof in a whole nother video, but for now we're just going to focus on knowing what these are about and the application of these equations. So now, the one thing that people really sometimes struggle to get is, when do I use future value and when do I use present value? But it's quite easy. So think of it. Future value says future. It's not now, it's somewhere in the future to happen. Still to come, it's not here yet. Present value says this is now. It hasn't happened, it's not going to happen, but it's happening right now. So then if you look at all the types of financial transactions, loans, investments, savings, and those kind of things, think about, well, when does my lump sum come into effect? So let's look at a few examples. If I'm going to go and take out a bond to buy a house, taking out a bond to buy a house, normally that happens because I don't have the cash in hand to go buy a house. So what I do is I go to the bank and say, listen, Mr. Bank, or Mr. Banker rather, could I please have $1 million? I'd like to go buy my dream house somewhere. So what happens is he gives me the money right now to buy the house, and I will pay him back over however many years. So the key thing there is, with that loan, I got the money now, today, in the present value. If I take out a loan to go buy a car and pay it back in monthly installments, again, I didn't have the money now, but I needed the money now to purchase the car. Mr. Banker, could I please have 200,000 Rand to go buy my first car? What happens? He gives me the money now so I can buy the car now. Present value, not the future, present. Okay, if I, let's say for example, thought I actually don't want to now get in debt and go loan money for a car, loan money for a house, but instead I'd like to save money in equal monthly payments to save up for my dream house or my dream car. What I then do say, oh, Mr. Banker, I'd like to put some money away so that I can one day buy a house or I can one day buy a car in the future. Again, future. So if you're going to now save money so that you can get a lump sum in the future, future value. So if they say, Susie comes and Susie wants to one day buy a house. She starts by saving 1,000 Rand a day, blah, 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 blah. If I start by saving money today because I want to one day have the lump sum to buy the house, future value. If I go take out a loan or anything like that to sort of get the money today, present value. Okay, it makes sense. So now, don't always think of loans as present values and savings as future value, because you could be on the other end of the loan. If I then come say, okay, you want a loan and I'm going to loan you money, and blah, 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 blah. In that case, I gave you a lump sum. And now, you're going to pay me back in monthly increments so that I one day get all my money back. That's future value. Even though it is a loan, it's on the other end of the loan. So on one side of the story, it's a present value. On the other end of the story, it's a future value, because one person gets the money today to pay it back in the future. And when someone's paying me my money back, that's in the future. I'm then receiving the lump sum in the future. and that kind of thing. Okay, fantastic. So now, these are two main equations that we can look at. So let's look at an example of either of the two. So let's first look at a future value example. So now, again, I'm here and I really want to buy my dream car and it costs me 200,000 Rand, and I want to actually now see, well, how much money do I need to save every month to be able to afford this car 5 years from now? Okay, that's okay. So I know that, okay, in this case, my future value, so the value I want to have in 5 years' time is 200,000 Rand. There we go. And let's say the bank says, well, we'll offer you the interest rate of, for example, prime minus 2, and let's say prime was like 10%, so you'd get 8% interest. So then your interest rate would be 0,8, right? Now, you want to see, well, how much money do I need to put away every month if I want to put away money and buy this car in 5 years' time? So now, my number of years is 5. So if you remember now, my N is 5 years. But wait, the bank says our interest is compounded monthly. So the very important thing to do now is to actually divide your I by M. So if you're going to say I divided by M, that's going to give you 0,8. Ooh, my mistake. It's 8% of 80%. It's 0,08. And this will be 0,08. Divided by 12 as compounded monthly, and now my N is going to be N times M, which is 5 times 12 years, which will give us 60. So now I've got my basic values all the way around here. Now let me find out how much I need to pay every single month into my account so that I can afford to buy my dream car cash. So what I'm going to do is I'm going to now plug my values in and solve for x, or I can rearrange the equation first and then find my x. So if I rearrange this equation to solve for my x, I'm going to multiply through by I and divide through by this entire bracket. So you find that actually my equal monthly payment is going to be equal to my future value times my I divided by that whole big bracket there, which is going to be 1 plus I to the power n minus 1. Then I can plug in the values I've got there and solve for an answer. Okay, so that's going to be 200,000 times 0,08 divided by 12 all over 1 plus 0,08 divided by 12 to the power of 60, that's my 60 there, minus 1. Then if we quickly work that out, we'll find that the answer will be 2,721, and if I round the cents off, and 95 cents. So if I pay this amount of money into my account every single month, in 5 years' time, I'll have my 200,000 Rand to be able to buy my car in cash. And that's basically how you'd apply your future value. Let's look at how we'd apply a present value. So for present value, let's imagine the same scenario. I want to buy my car, and now actually I don't have all that money sort of put away. I don't have the time to wait for 5 years. I need a car right now. I just got a new job very far out of town. I need to get a car so I can travel there every single day. So now we look at the present value equation. So now we need the 200,000 Rand to buy the car right now. So my present value is 200,000 Rand. Okay? The bank says, well, we'll give you the exact same interest rate. So then my interest rate is going to be 0,08 divided by my 12. My N, number of periods, will be 60 because it's 5 years of 12 months each. Okay, now let's see what we get. And then I'll do the same thing to work out my monthly installments by rearranging my equation to solve for x. So then x will simply be, if I multiply through by I, at the top I get my PV times my I. At the bottom I get that whole other bracket there, which is going to be 1 minus bracket 1 plus I to the negative n, like so. And if I plug the values in, it's 200,000 Rand times 0,08 divided by 12 all over 1 minus 1 plus 0,08 over 12 to the power of negative 16. Let's plug that in and see what we get as an answer. So in this case, I'd need to pay 4,055 Rand and 28 cents. Notice that massive difference between if I were going to save up to buy a car in 5 years' time versus if I was going to get the car now and pay it off. So that's nearly double the amount of money, purely just because you couldn't wait the 5 years or so on. But I mean, everyone has different life circumstances and no judgment at all. But that's the key difference between saving money to buy something cash versus taking the loan out and paying it back. The other amount is significantly higher. And that's basically how we apply our present value and our future value equations. Okay? Now, go try some examples, see how that goes, and then we'll try some more difficult ones involving timelines and sinking funds in a bit. Awesome.